In this video, I want to look at reference angles. Reference angles are extremely important in trigonometry because what it means is that all of the angles, all of the ratios, sine, cosine, and tangent, all of the ratios, no matter what angle you are exactly the same as an angle in the first quadrant. In the first quadrant, the only difference is if it's positive or negative. So reference angles become a very important piece of this in that all of the ratios are found between 0 and 90 degrees, or 0 and pi over 2 radians, and they just repeat around the circle. And we get into the unit circle, all of those ratios are exactly the same as they were in the first quadrant. So if you can figure out what the angle, what the ratio would be in the first quadrant, then all you have to worry about is if it's positive or negative. And that's determined by which quadrant it's in. And we'll get into that in another video. The definition of a reference angle is very, very specific. A reference angle is the positive, acute, that means less than 90 degrees, angle between the terminal side, where the angle stops, and the horizontal axis. So it's very important, it's this angle between the terminal side, this side, and the horizontal axis. It's the positive acute angle between the terminal side and the horizontal axis. If you're in quadrant 1, it's very easy. If you have an angle here, this is the initial side, this is the terminal side. If you notice, that's an acute angle between the positive x-axis, or between the horizontal axis and the terminal side. So the theta and the theta reference, and this is how I'll reference it, theta reference angle is equal to theta in the first quadrant. If I'm in quadrant 2, notice here's my angle. This is my terminal side. Okay? So the reference angle is the positive, acute angle between the terminal side and the horizontal axis. Here's the terminal side, here's the horizontal axis. It's the positive acute angle between the terminal side and the horizontal axis. So that's my theta reference in the second quadrant. Now to find that, if I know this angle, and I know this whole angle is 180 degrees, then to find the reference angle, to find this angle, I subtract this angle from 180 degrees, and that'll give me this. So in the second quadrant, it's 180 degrees minus theta, or the whole angle in radians would be pi radians minus theta. Here's an example. For example, if your angle is 130 degrees, theta reference, 130 degrees is in the second quadrant, it's greater than 90 and less than 180, so it's in the second quadrant. Theta reference is equal to 180 degrees minus theta, which is 50 degrees. So this angle here would be 50 degrees if this is 130 degrees. If you had it in radians, if you have theta as 3 pi over 4 radians, 3 pi over 4 is in the second quadrant, so the theta reference would be pi minus the theta. Get common denominators here, 4 pi over 4 minus 3 pi over 4, and that gives you pi over 4. So my reference angle for this angle is pi over 4. There's an interesting thing there, and I want to do it, I'll look in the next slide, and I'll point it out in the next slide. See if you notice something between here and here. Quadrant 3. Quadrant 3 is down here. 1, 2, 3. So my theta is this big blue angle. I know this 180 degree angle is the horizontal line. Okay, and again, the reference angle is the positive acute angle between the terminal side and the horizontal axis. So it's this angle. This is my reference angle. So to find this, if I know this whole angle, and I know this is 180 degrees, then this angle is equal to my whole angle minus 180 degrees. So that's my theta reference. Similarly, if you're in radians, if theta is in radians, so it's theta minus pi, because this would be 180 or pi. So if I subtract that off the big angle, then what I'm left with is my reference angle. For example, theta is 225 degrees. My theta reference, then, from the formula, is equal to theta, what was given, minus 180 degrees, which is equal to 45 degrees. Theta is equal to, if we're looking in radians, theta is equal to 5 pi over 4. So from here, I subtract pi from my theta, common denominator again, and 5 minus 4 is just pi over 4. You should recognize something. Getting from here to here. One more time. Quadrant 4. So now I'm all the way over here. This blue line, this blue angle represents the whole angle that I'm at. I'm way over here in the fourth quadrant. So if I know this whole angle, or I know the blue angle is theta, and I know the whole way around the circle is 360 degrees, so to cut that off and give me what I have left, which is my theta reference, which is the positive acute angle between the terminal side and the horizontal axis. So it's this angle between the terminal side and the horizontal axis. So my reference angle is equal to 360 degrees. If I take this piece off, that leaves me with my theta reference. So it's 360 degrees minus theta. If I was in radians, it would be 2 pi minus theta. For example, theta is equal to 330 degrees. Theta reference is equal to 360 minus theta, which gives me 30 degrees. So this angle here is 30 degrees. If I'm in radians, theta is equal to 11 pi over 6. Theta reference then is equal to 2 pi minus theta. 2 pi with a common denominator of 6 would be 12 pi over 6. Subtracting 12 pi minus 11 pi is pi over 6. You should have recognized from the last 3 slides that the reference angle for an angle in radians is very easy. If you cover up the number, pi over 6 is the reference angle.